Okay. Okay. Question 2 now. Question 2 is also easy because it's number 2, x plus 4y plus 2z equal 3. Equation 1. By y plus 3z equal 4. Equation 2. And the last equation is z is equal negative. It's so obvious when you see the system like that, okay, because this is some term is missing in the equation, no? You apply always back substitution. Because I know directly z is equal negative 2. Look at this equation. With substitution here is 5y plus 3 times negative 2 is equal 4. 5y minus 6 equal 4. 5y is equal 4 plus 6 is 10 divided by 5. It's obvious that y is 2. And taking the last equation is x plus 4 times 2, because I know that the y value is 2, plus 2z and c is negative 2, should be 3. So x plus 8 minus 4 equal 3. X plus 4 equal 3. X equal 3 minus 4. X equal negative. The solution is negative 1, positive 2, and negative 2. Solution is the triple order. Negative 1, positive 2, and negative 2. Que corresponde with the option A, no? In the handout. And there's no multiple choice. In the review packet, yes. Because I want to make sure the answer, no? Any question? Super easy, eh?
Yes, sir.
Okay. Let's move on to the question 3. Question 3. Question 3 is one system is given again. Okay. Look. Is x plus y plus c equal 10. This is my first equation. My second is x minus y plus 3c equal 14. And 2x plus 2y plus 2c equal 12. What do you think about this system? What do you consider without do anything, using intuition, imagination? We have solution or no? And why no? And why yes? Or no idea? No solution. Why no?
Because the first one and the third one are basically they're just multiplied by 2, and they're not the same answer.
Exactly. Joy saw the equation 1 and the equation 3. Look at what happened. If you divide by 2, the entire equation 3, we have x plus y plus z. It's exactly the same of the left-hand side in this equation. But in this equation is equal 10, in this equation is 6. So basically, this is equation 3 after the transformation. They are a contradiction. 10 and 6 is not equal. Okay, therefore, it's obvious no solution. However, suppose that you don't see that. Okay, no problem. We are doing by the long way that we are doing the test 2, no. I propose you smart way. Doing, suppose that you don't see this, okay? I understand very well. We are doing the solution using matrices. And you create the matrix, the augmented matrix associated with the system, que es 1, 1, 1, 10, 1, -1, 3, 14, and 2. Because I don't realize that it's possible to divide by 2. No, no, I don't care. It's 2 do 2 and 12. No? And you go to the GeoGebra Classic and apply the function reduce row echelon. And let's see what happens. I have no idea. Okay, look at that. Let me go to the GeoGebra Classic. Okay, do you see GeoGebra Classic?
Yes, sir.
Okay. Here, I type in my entry. 1, 1, 110. Second row, get the second equation. 1, -1, 3, 14. Third equation is 2, 12. Just in case, I recommend checking to detecting any mistake. Okay, I select everything. Hey, what the hell? This is my mouse. It doesn't work very well. Select everything. Select everything. Oh, yeah. Select everything. Wow. Select everything. Okay, let me select everything in different way. No, no. My mouse. Select everything. No. Select everything and right click on a right click and create matrix. Okay. Something wrong. Something wrong. This is 12, not 36. What the hell happened here? Delete. No equal sign, just 12. Okay, let me try using the mouse of the laptop. Okay, I click here. Drag. Okay, good. The mouse of the laptop works. Because I have wireless mouse, I suppose that the battery is not good. Now, right click. Select create. Select matrix. And the matrix is M2, not M1. Let me delete this matrix M2. So you apply reduce row echelon, reduce it, reduce the row echelon of the matrix M2, no? M2. Press enter. Ah, I get that answer, right? Okay. I want to copy in the board the answer and interpretation that answer. Okay. Okay. Switching to the board. Okay. Okay, I am here. Okay, the answer was 1, 0, 0, 0, 2. This line in the software, we have not this line, but this is a line I put to separate the coefficients from the variable and the right-hand side number, no? 0, 0, 1. This is 1, 0. And this is -1. Okay, this is my matrix, my new matrix. I suppose it's equivalent to the original. After you apply the reducer row echelon. So what is the problem? The problem I can see in the last equation, look, I can see the contradiction. Why? Because when you translate, remember, this is column of the X, this column of the Y, this column of the C, this is the right-hand side number. I can see que X times 0, que es 0, plus Y times 0, que es 0, plus C times 0, que es 0, so 0 in the left-hand side is equal 1. And it's completely false, and that means that we have no solution. Inconsistent, no solution. Any question? Any question? No. Everything clear?
Yes, sir.
Okay, anyway, you prove me using the intuition or no? Suppose the intuition is hard and the example exactly on the test. And you create the matrix, apply the software, reduce the row echelon function, and you get the basic contradiction or no? Or no? Okay, let's continue. Okay. Example 4 is, wow, it's a piece of cake. Example 4 is a stupid answer. I promise in the test you can see this kind of a stupid answer. It's my gift, no? Suppose the system is giving 3x plus 9y minus 5z plus w. So we have 4 variables equal 5. My first equation. My second is incomplete, is 6y plus z. The x is missing, w is missing, equal -2. Equation 2. The third one is x minus y minus 10z, no w, equal -2. This is equation 3. And the last one is 12x minus 12y plus 2z equal 11. Equation 4 is a system for equation for unknown determinant, but they want only you write, look at the question. The question is stupid. You write the augmented matrix of the given system of equations. The common mistake, no mistake, the students are doing well always, but the student try to solve it also. No. The question say write the matrix. So the matrix is a big matrix. Remember the organization, the column of the X, the column of the Y, the column of the C, the column of the W, I separate by the line and the right-hand side. And we are doing equation by equation. 3, 9, -5, 1, and 5. The second equation, X is missing, no X, 6Y, 1Z, and missing W, equal negative. The third equation is 1 in X, -1 in Y, -10 in C, and W missing. And the right-hand side, -12. And the last equation is 12, -12, +2, 0 again, 11. By the way, it's important, when you write the matrix, write the dimension. Okay? In this case, 4, because we have 4 rows, 1, 2, 3, 4, and 5 columns. Final answer. This is the answer I need. Any question? Any question?
No, sir.
One last question, Professor. I'm so sorry.
Go ahead.
And the question example is going to say write in form, correct? What's the question going to say? Just so I don't confuse it.
Write the augmented matrix of the given system of equations. Augmented matrix means you connecting A line B. This is augmented matrix. A is the matrix A is that part.
Perfect. Thank you, Professor.
And B is the right-hand side number gets that part. This is technical. Technical name is augmented matrix. Okay, because it's the original matrix A plus the right-hand side. Super, no problema. Easy, it's my gift. Don't try to solve it. Reduce row echelon. No, no, no. Not wrong, but you waste the time. Okay? Keep going. Moving on to the next example.
Yes, sir. Keep going.
Okay. The next example is a little bit long and complicated because it's row operations. Row operation. Okay. Let me go to question 5. Question 5, 6, and 7 is a row operation. This is the question I talked to you. It is by hand. This is possible doing by software, pero in graphic calculator. Pero no. Let's do it by hand. Question 5 is one matrix given. The matrix is 1, 2, 3, negative 3, negative 5, negative 5, negative 5. Wow, how many negative 5? 2, 4. Okay. 2, 5, 6. 2, 5, 6. This matrix is 3 by 4. 3 row, 4 column. Entonces, day 1, you perform row operation on this matrix in this sequence. Okay, this the first one. You need to understand the notation that they using in the handout. It's R2, capital R2 is equal minus 2 R1 plus R2. And let's do it one by one. Okay, but this is sequentially. So we perform the first row operation on the original matrix. The second row operation you perform in the new one, not in the original again. But no, wait, don't worry. Let's do it step by step. Okay. So what is the notation? What is the reason that using capital R and little r? Well, capital indicate the new one, and little r is the old. Okay, so the new row 2 is formed by this mathematical expression. That basically, I know that the only row that participate in the game is row 1 and row 2. Okay, row 1 and row 2. Therefore, row 3 stays the same. Don't participate in the game. I copy exactly the same. But and also I know even the row 1 participate in the game, the final answer is storage in the row 2. And the only row we change is the row 2. The row 1 stays also the same. Everyone follow me with this idea? Now let me try. Let me try, but let me try to organize the calculation in that way. Look, minus 2 row 1 plus row 2. Store in the new row 2. I copy negative 2, negative 2, negative 2. How many times? 4 times. Because we have 4 column, no? So row 1 is 1, minus 3, minus 5, and 2. Look, I copy that, and row 1 get this. Plus row 2 is 2, negative 5, positive 2, and finally 5. Okay, and this information I store in row 2. Therefore, this is 0 because the negative 2 plus 2 is 0. This is 6 positive. plus or minus 5 is 1. This is 10. And 2 is 12. And this is negative 4. Plus 5 is 1. Entonces the answer is 0, 1, 12, and 1. Everyone follow me? Everyone understand very well this? Welcome from this? I know it's too long. This is not the point. But it's understandable. You have time to do in the test, step by step. Okay, question. Everyone saw that or no? Confusing, very confusing, Professor. I don't understand anything. Come on. Clear? Confusing? Giovanni?
I'm good.
It's okay.
It's you got to keep doing practice, a little more repetition. That's
Absolutely. That is the reason that we have 5, 6, and 7. 3 problems, little by little, and you redo again at home. Okay? Okay. But I finish, no, because I need to perform 3 row operation, no? The second is row 3 is equal negative 3 row 1 plus row 3. Okay, now then in the next row operation, participate in the game row 1 and 3. However, the only row that changed is row 3. So I copy exactly the same row 1 and 2. This doesn't change. But 3 no, 3 change. According to this mathematical expression, minus 3 row 1 plus row 3, this is letter R, equal R3. Minus 3 times. So I copy here the row 1, the previous, no? Oh, no, by the way, it's the same. So it's 1, the factor is repeated. The basic of the row operation is you select one factor, multiply by each element 1 by 1 of the row 1, plus the corresponding in the same position, row 3, 1 and negative 3, no? And negative 5, positive 2, and you adding by the corresponding element in the row 3 gets 3. Look, this one in the same column, no? Negative 5 here. Positive 4. And 6, no? Okay, this is 0 again. And you put a 0 here. This is 9 plus 4. This is 15 plus 4, 19. And this is 0 because it's negative 6 and positive 6. Okay, this is my second matrix after the.
Isn't the second one negative 14, not 4? Negative 9 plus negative 5.
Which one you say this?
Negative 3 times negative 3 plus
no,
negative
1 up.
5. The 1 up.
Negative 3 times negative 3 is positive
Negative,
9.
oh, hello, never mind. You're right.
No, it's okay. You go
right.
me.
I thought the same thing.
I'm sorry.
Don't hesitate to see you don't understand something. You don't hesitate, Professor. You make a mistake. I am human. Okay, R3. Okay. So everyone follow me in this idea, the second transformation. Remember, the original was history. I am doing progressive 1 by 1. So now the last transformation is row 3 is equal 5. It's a factor. Row 2 plus row 3. And storage and row 3. So I understand very well. Okay, the row 1 and 2 stay the same, the only row can now change is row 3 because it's the, and you copy now 5 times time 5 times row 2 plus row 3 storage and the new row 3. 5 times 0 plus something. 5 times -3 plus something. 5 times -5 plus something. 5 times +2 plus something. And the something is the row 3. Row 3 in the previous is 0, 4, 19, and 0. And the answer is 0. The answer here is 15, no? 15, 15, 15, no? 15, 15, 15, right? No, wait. 15 plus 4 is 11, no? -11. But I make a mistake in my calculation. Let me see. 0, -3, -5, and 2. Uh, 0, 4, 19. Okay. Entonces -11. Entonces now es 25. 25 minus 19, ¿no? Es 6, ¿no? Es -6. Es -6. And this is just 10, no? Something is wrong. 4, 0, 5. Because maybe I'm using another factor. Okay. 5 R2.
But didn't you use, you multiply row 1, not row 2.
Yes, you're right. That was my big mistake.
Okay. That was confusing me.
Yeah. So you can
Okay.
me. Okay. Is you select the element in the row 2. The element in the row 2 is okay. F5. 5 times 0 is this 0. The row 2, no? Row 2. Plus something. 5 times 1, no? No -3. Plus something. 5 times 12 plus something. And 5 times 1 plus something. And the row 3 is 0 is 4, no? 19 and 0. Okay. Entonces es 9, no? Es 9 here. Good. This is 60, 79, no? And this is 5, 79. And 5. Now it's clear. Okay. This is the answer. Okay, the answer, by the way, corresponded with the option B in the handout. Let me check it. Yes. See, I make a mistake here. Okay, I don't know why in my mind I create row 1. It's not row 1, row 2. Row 2 is this. So that's important. This is the, when you are doing using the software, the reduced row echelon form algorithm is something like that. But you are doing one by one until you finish. In this case, no. In this case, I asked you in the test only 3 row operations, and that's it. And you are doing by hand. Let's practice, guys. Let's practice. Any question? Anyone follow me? Complicated?
Got it.
Got it. Okay. Good. Let me erase. Let me go to the second example. Second, no. 6th question is the second example of the row operation. Okay, the matrix given always 1 minus 3, 2, 2, -5, 0, -3, 8, -1, 4, -10, 4. And you have to perform the following. Row 2 is equal 3 times row 1 plus row 2. Okay, let's do it one by one. So I copy my matrix, and my matrix is basically in this row operation participate 1 and 2, no? But 2 change and 3 no participate. So 3 stay the same. 1 stay the same. The only guy can change in row 2, no? So it's 3 times row 1 plus row 2 torch and row 2. So 3 times, 3 times, 3 times, 3 times. I copy now row 1. Row 1 is 1, 2, -3, and 4. Plus row 2 is -3, -5, +8, and -10. Okay. Okay. Now you get in the row 2 0 here. Because +3 and -3 is 0. You get 1, no? 1, 1, 1, because it's 6 minus 5. You get that a -1 because it's -8 plus -9, sorry, plus 8 is negative. And finally, well, -1 here. And finally, this is 12 minus 10 is 2. Okay, no problema. Let's do in the second one. The second is, well, -2 row 1 plus row 3 stores and row 3. So now I can see that the row 1 and the row 2 stay the same. 1, 2, -3, 4, 0, 1, -1, 2, and the only row can change is row 3, no? So I copy -2 4 times, it's a factor. I copy vertical now, the row 1. I don't know, this is, at least for me, is the best way to see that. You can see mentally, but I need to explain, but to explain something, I need the paper or the board to write, you know, because see, I try to do mentally the operation, you are lost. 1, 2, -3, 4, plus. So I copy the row 3, okay, again vertical. But what row 3? This is the old one, no? Row 3. It's 2, 0, 2, 0, -1, and 4. Okay, this is 0 again. Yeah, I copy in that position. This is -4. Very well. The 2 times 2, no? But it's negative. This is -6. No, this is 6 positive F5. F5. The -4, 5. And finally is -8 and -4. Super. And the last row operation is 4 times the factor is 4. Row 2 plus row 3. Store and row 3. Well, I copy. I copy 1 and 2 exactly the same. 1, 2, -3, 4, 0, 1, -1, 2. In the only row we change again, in this case 3. 4 times something, 4 times something, 4 times something, 4 times something is row 2. Row 2 is 0, 1, -1, and 2. And row 3 is this row. Row 3 is 0, -4, positive 5, and negative. Well, this is 0, it's obvious. This is also 0. Wow, 0, 0, 0, 2, 0. This is 1 because of 5 minus 4. And this is 4, no? Because of 8 minus 4. Final answer, que corresponde with the option A in the handout. Any question? This is easy, guys. I know it's long, but you repeat several times. Unfortunately, well, let me explain something. The student can have graphic calculator like a TI-83, 84, 89. There are possibilities doing step by step. I try to find in GeoGebra and internet, and GeoGebra indicates there exists a row operation, but I try, but at least in my computer doesn't work. I don't know why. But okay, behind that, this is number 6 problem. Any question? Clear? Now let's go to number 7. Number 7 is higher dimension, but this is only 2 row operation. No? Number 7, we have a big matrix. Very big matrix. Okay, is 1, 1, wow, 1, 1, negative 1, 1, line 3, 0, negative 5, 1, negative 2, 0, 2, 0, negative 3, negative 4, and 3. Negative 5, 1, 0, 5, and negative 4. The dimension diameter is 4 by 5. 4 row, 5 column. And the row operation I need to perform is, the first one is negative 3, row 1, plus row 3, storage, and row 3. Okay, entonces I copy, the majority of the numbers stay the same. I copy the row 1, it's exactly the same. I copy the row 2 exactly the same because do not participate in the operation. Okay, 1, negative 2, and 0. No, row 3 change, but row 4 no. And negative 5, 1, 0, 5, and negative 4. So let's copy negative 3. How many times? 5 times, no? 5 times because each row contains 5 elements. Negative 3, wow. Negative 3, 5 times. Wow, my mouse again. Okay. Negative 3 times something. Negative 3 times something. Negative 3 times something. Negative 3 times something. And negative 3 times something. I copy the element in the row 1, que es 1, 1, negative 1, 1, and 3. This guy. Row 1. Plus, I like parentheses because I copy the number in the row 3 using, of course, the corresponding sign. And after you change the sign, no? So says row 3, but what? Which one? Row 3, this is row 3. The old one is 2, is 0, and negative 3, and negative 4, yes, 3. Okay, this is negative 3, this is negative 1, I suppose. Yeah, negative 1. And this is negative 1, I copy here. This is negative 3, I copy here. This is 0, no? 0, 0. Because it's positive 3 and negative 3 is 0, 0, 0, 0. And this is negative 7, no? Christian Leva. Negative 7, Christian. Help me, Christian. And the next one is a 6. A 6 or negative 6? Wait. Is Es negative 6. Negative 6. You're right. Es negative 6. Wow, what the hell? Negative 6. Okay, that was the first transformation. Let's move on to the second one. Okay, the second transformation is R5. The factor of 5, R1 plus R4, torch and R4. So I copy exactly the same. Everything except the last row. 1, 1, negative 1, 1, 3, 0, negative 5, 1, negative 2, 0, negative 1, negative 3, 0, negative 7, negative 6. Okay. The last one, no. The last one change. I copy 5 times something, 5 times something, 5 times something, 5 times something, and 5 times something. 5 element. It's the same because it's a row 1. It's a coincidence, no? So it's 1, 1, negative 1, 1, and 3. Plus 4 element and the all row 4 is this. Row 4. And negative 5. A1, A0, A5. Y es negative. Entonces, let me see. The first guy is 0, no? Because 5 positive, 5 negative. 0. The second guy is 6, no? So the 5 plus 1. The third is negative 5. Because it's 0 here. This next is 10. The 5 plus 5. Negative 5 here, 10, and 11. 11. The 11, yeah. Because it's 15 positive, minus 4 is 11. 11 positive. And this is the final answer que corresponde with the option C in the handout. Any question, guys? Do you understand very well or no? Giovanni, let me know. Clear now? You have to practice. I propose, I don't know, Giovanni, okay. I propose this organization. No? So you like this organization, you use it, no? Remember, the algorithm, mathematical algorithm is repetition, 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 several operations, no? Of course, we're using software sometimes, no? Entonces it's easier. But in this case, you need to show me by hand. Okay. Let's move on to the question 8. Question 8 now. Okay, question 8. Don't worry, guys. I need to make sure everyone understands very well. One of the students that want to learn. The student can participate with me in every lecture. No? The student that do not participate, well, I don't know. That's your problem. Number 8 is the system. Entonces, if no specification, any method, you apply either method that you want. Minus y minus 6c is equal minus 7. Equation 1. The second equation is minus 7x. Y is missing, no y, plus 3c equal minus 29. Equation 2. And equation 3 is 9y positive plus equal 70. Entonces the question say, solving the system of equations using matrix, row operations, that we are using, of course, software, because one by one row operation is crazy. You spend one day doing the one system. If the system have no solution, as you say, it's inconsistent, no? Otherwise, well, you determine if we have one solution, unique solution, infinity many solution, or no solution, no? Okay, so I recommend one more time doing the augmented matrix like that. A and B separated by line, augmented. In our example is -2, -1, -6, -77. -7, 0, y missing, 3, -29. And 0x, 9, 170. This is my rate. Dimension 3 by 4. And you put in the algebra, of course, and you apply, what the hell is that? And you apply the famous reduced row echelon form. And let's see what happens. An interpretation of this answer. Let's move on to the algebra. Okay, let me try. Okay. Okay, and okay. You see? Okay, I copy the numbers. The number are -2, -1, -6, and -77. The second row, get the second equation, is -7, 0, 3, and -29. Okay. The last equation is 0, no x is missing, 9y, and 1z, and 70. That's the right answer. Okay, let me try again. You select the matrix. Boom. Again, the problem of my mouse. I need to change the battery. So you select the matrix. Let me try. Selection. 1, okay. And you create the matrix. Okay. It's a question mark. Unbelievable. Okay, delete. Okay. This is 72. 72. Selection. This is the complicated part in my computer now. Selection. 72. Let me try to using the mouse. I don't like the mouse of the laptop. Okay, selection again. I don't know, selection, not the row. Selection, only the cell. Selection. Okay, good. Right click. No, coño. Okay, selection again. Selection. Click in this cell. Drag. So, right click. Select, create matrix. Okay, M1 is the name of this guy. I put it here. Okay, I put it here in the cast. Reduce the row echelon. Okay. Of the matrix N1. N1. Boom! And this is the answer. Let me copy this answer and the whiteboard. Let me try. Look. The answer is 1, 0, 0. 0, 1, 0. 0, 0, 1. The line is separate the variable and the
You're still in Geo.
Sorry. Well, the only thing I did was copy the answer of the algebra in the board. Okay, look at that. I copy. Do you see?
I see.
Yes or no? Okay.
Yes.
Now, interpretation.
Isn't that have
think?
zeros? No solution? We
No
saw
solution.
a problem like this last week. It's one of the rules.
Okay, entonces,
It's no solution to zero.
one opinion is no solution. Everyone is agree or disagree? Everyone is agree or disagree? No solution. Remember, we have three possibilities, no? No solution, infinity many solution, or one solution. Come on, opinion. Hey, are you there? Come on, student in my classroom, opinion. Adrian, opinion. Jonah, hey, Jonah, how's it going? I need to talk to you when the class is over. Jonah, okay? Do you hear me, Jonah Moreno? Jonah, do you hear me? Yamil, Bianca, Harun. Nobody have opinion, guys. Ay, ay, ay. What happened with my student pre-calculus? Okay.
All right. It says no solution. When I have
No. I totally disagree with you. Totally disagree.
For...
How you identification this? You can see clear like a water. Look here, the identity matrix. Identity matrix, dimension 3. When this situation happens, complete identity matrix is only one solution, unique solution. Unique solution, one solution. How do you know? It's easy, look at that. Translate from matrix to the equation. Look, the first row, this row, is 1x, 0y, no z, this is missing, equal 8. This is obvious que this equation is equivalent to say x equal 8. Likewise, the second row is y equals 7, and the last row is z equal 9. End the story. One solution, unique solution, unique, but not like that, unique solution. Okay, the solution is 8, 7, 9. So when you see the typical format, look at that. This is a moment to learn. I explained in the lecture. This is a review, coño. Look, you have this format. You have here identity function. Suppose dimension 2 or dimension 4. 1, 2, 3, 4. And the rest is just 0. And the right hand side, I don't care. We have number 8, 7, 9, 10, whatever. 7, 5. This is a typical format of the unique solution because x is 7, y is 5, x is 8, y is 7, z is 9, and w is 10. And the indicator que unique solution is because we have the completely full identity matrix. In this case, identity matrix dimension 4. In this case, identity matrix dimension 2. In one hypothetical example, no? But in our real, actual example is identity matrix dimension 3. Do you understand very well or no? Do you?
Yes, I understand it.
Okay. And the rest of the students? Jonathan, are you awake or no? Jonathan Moreno. Wow, sleeping, no? I have feeling it as this. What do you say was? Christian, what is your concern? Christian, come on. Try to speak or activate the microphone, whatever you want. What is the problem? Guy, this is a review. This is the last time you see that. You need to understand very well this. Okay? I bring a lot of complicated examples. I have feeling and it was unique. I have feeling. No feeling. It's no feeling. It's a fact. It's a fact. But do you understand what is the format to understand a unique solution, right? It's identity matrix, boom, 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 boom. And the right-hand side, we have number. Okay. No more complication. No more complication. Any other smart question? Come on, no question. Okay. Okay. Let's move on to the number 9. Number 9 now. Number 9 is a little bit different. Number 9 is a little bit different. Pay attention. Number 9. Number 9 is AX minus 7Y plus 3Z equal negative 122. Equation 1. Negative 40x plus 35y minus 15z equal 610. Wow, big number, but I don't care. I use it software. 16x minus 14y plus 6c equal negative 24, negative 2,244. Equation 2. Okay, I have no idea. Totally lost. I set out the matrix. The matrix is A, negative 7, 3, the line, negative 122. This is my first row, okay, my first equation. Negative 40, 35, positive, negative 15z. No, hello, no variable. In the matrix, never variable. 15 and 16. And the last equation is 16, negative 14, and 6. And equation, and this is negative 244. This is the matrix form of the system. In this case, the dimension is 3 by 4. 3 equation, 1, 2, 3. 4 column, case the 3 variable x, y, z plus right hand side. So I have no idea. Okay, no problem. I put in the GeoGebra. I try to solve it using reduced row echelon. I'm surprised. The most important is the interpretation. Okay. I go to GeoGebra. Okay. Let me switch in the screen to GeoGebra. Switching. Here. Switching. There you go. GeoGebra now, huh? You see or no? It's 8. Negative 7. 3. Negative 122. Okay. The second equation is negative 40. 35. Negative 15. 610. Okay, super. Last equation, 16. Negative 14. 6. Negative 244. Okay, this is my system. Guy, it's important you checking see everything is okay or no. Okay, so you change one number or you change one sign, we are solving totally different problem. Don't expect the answer. Okay, now right click. Oh, right click. Okay. Never using my wireless mouse. Okay, I click here. I drag. Okay, right click. Ay, carajo. Okay, again. Let me try again. Drag. Wow. What's going on? Do you see or no? Okay.
Yes, sir. We see.
You know,
We see it, sir.
no,
It's just it's your
I
mouse.
minimize. I am in big. hard time with the my mouse. Okay, let's see. And there are two, it's okay, but I don't have practice. Now write, select create, select matrix, and the name of this matrix M3. Okay, super. And one more time, you are doing reduce echelon. Reduce echelon of the matrix M3. M3. Boom! Here's the answer. Here's the answer now. Wow, what the hell is that? Let me copy in the whiteboard an interpretation. Let me copy in the whiteboard an interpretation that. Okay, whiteboard. Switching to the whiteboard. Whiteboard interpretation. When you perform the reduce the row echelon form, we get that. Look. 1 negative 7 over 8, 3 over 8. The line can separate the coefficients from the variable on the right hand side, 61 over 4. And what happened with the rest? The rest is 0, 0, 0, 0, 0, 0, 0, 0, 0. Okay, now interpretation. Who helped me to interpret that? Remember, we have three possibilities. You need
Multiple solutions.
Multiple solution. Multiple solution. It's okay. Multiple solution. So we have solution, but it's multiple solution. Infinity many solution or no solution. It's obvious. Joyce say it's multiple solution like that. Okay. So immediately, when you see multiple solution, infinity many solution, you determine how many free variable. So how many free variable. Entonces, to determine how many free variable we have, you try to find the identity matrix. Identity matrix is a matrix like that. Look. Identity matrix, dimension.
You're not on whiteboard, sir.
No?
No.
No.
Okay, okay. And now?
Perfect.
Okay. Okay. Entonces, you see guess infinity many solution, right? But how many free variable? Well, I have no idea, no? Remember, to identification, the free variable. How many free variable? I need to find the identity matrix. Suppose identity matrix dimension 2. This is I2. Or identity matrix dimension 3. It's something like that. Or 4, right? In this case, we have only one here. Okay, I suppose, using my imagination, is identity matrix dimension 1. It's just 1. 1 by 1, no? This is 2 by 2. This is 3 by 3. Yes or no? Do you see that? And the rest of the column is this. And this represent the free variable. Now the answer for this question, how many? 2. 2 free variable. What is the free variable? Okay. This is X, this is Y, and this is Z. I suppose that Y and C are free. Y and C are free, and X no. Therefore, I write this row as an equation. It says X minus 7 over 8 Y plus 3 over 8 equal minus 61 over 4, because the only equation is stay alive, because the rest is deleted. And I try to analyze why it's deleted. So elimination process discover that 2 equations are dependent. It's the same equation. That's the reason that we have 2 free variables. Now, how you write the final answer? How you write the final answer? The final answer is I discover X que es the non-free variable, is equal negative 61 over 4 plus 7 over 8y minus 3 over 8z. I forgot here C. Look, C. Entonces, solution set es infinity minus 1. Infinity minus 1. Es the triple order x, y, z. Because we have 3 variables. So this belongs to the R3 space such that x is equal. And you copy this equation, minus 61 over 4 plus 7 over 8y minus 3 over 8z. And what about y and c? Y and c are all real numbers, que es sinónimo to say que es free. And suppose que if we have two free variables, it's because the solution look like a plane in 3D. Because maybe you have one free variable, it's because it's a line. Because dimension of the line is 1 and dimension of the plane is 2. Okay, let me try. Look, let me try to understand why happened that situation. Look, if we come back at the beginning, look, you can see, look, you can see the relationship exists between, for example, the row 1 and the row 2. So if you multiply the row 1 by negative 5, 8 times negative 5 is negative 40. Negative 7 times negative 5 is positive 35. 3 times negative 5 is negative 15. And 122 times negative 5 is 16. Let me put in my calculator. 122 times 5. Yes, it's 16. So basically, this equation and this equation are dependent. It's the same thing. Because when you multiply by negative 5, so row 1 times negative 5 is equal row 2. They are dependent. Likewise, happen in between row 1 and row 3, but multiply by 2. Let's see, so you multiply 8 times 2 is 16, negative 4, negative 7 times 2 is negative 14, 3 times 2 is 6, and negative 100. 22 times 2 is negative 244. So basically, the 2 factor multiplied by row 1 is equal to row 3. That is the reason that elimination, because at the beginning, you don't need to see that. You don't realize this situation. However, when you apply the reduced row echelon operation, Gauss-Jordan algorithm, Gauss-Jordan discovered that the equation 2 and equation 3 are dependent of the equation 1. Therefore, it's gone. And you can see get 0, 0, 0, 0. Guys, any question? You need to be prepared or you need to be ready to understand this because I promise in the test you see similar situation or a little bit more complicated. Any question? Any question? Good. Very good. Very good. Okay, no problem. That was example 9. Okay. So we have time or we have no time to cover. See, yeah, we have time a little bit, 3 minutes. But not completely maybe, no? Example 10. Example 10, exactly the same. We are doing similar. Example 10 is, look, 10. 10 is x minus y plus 3z equal negative 2. Equation 1. 2x plus c, no y is missing, equal 1. Equation 2. X plus 5y plus c Equal 26. Equation 2. Okay, this is my system. You write immediately in matrix language. 1, -1, 3, -2. 2, 0y, 1z, 1, 5, 1, 26. Okay, super. No. What should I do? What should I do? What should I do? I put in GeoGebra. R, R, E, F. Okay. Let's try quickly. At least one. Okay, one more. Switch it to. And you are doing with me simultaneously GeoGebra? Okay. Giovanni, it's okay. Now look. This, let me see if I make a mistake or no. 1. Carajo. Wait a second. What's going on? This mouse is terrible today. I need to immediately I need to fix the battery. I have a lot of battery, coño. Okay. Oh, okay. Time is over. Okay. Let's do it again. Number 10 with the new battery. Okay. Thank you so much. Jonah, are you there?
Professor, thank you again. Have a great day, sir.
You too.
Okay.
As always, you pay attention. You are a good, excellent student. Jonathan Moreno, stay here. I want to talk to you. Sé lo que pasa.